Learn, grow, succeed with TiwarisAcademy.
Jai Shri Krishna, Radhe Radhe. Welcome to recorded videos of TRIGONOMETry. My name is Tiwari. In today's video, we are going to talk about heights and distance. Now, what is heights and distance? Okay. First, we'll just write down what is heights and distance. Now, when we talk about heights and distance, basically, heights and distance is a part of application of trigonometry. Okay, it's a application of trigonometry. Now, you must be wondering how do we call it as? Why do we call it as? In fact, why it is called as application of trigonometry? Now, we saw how trigonometry was used in a right angle triangle. Okay, now we learned everything that trigonometry, basically all the rules, Shokatova, sine, cos, tan, we could use them on a right angle triangle. So can you just imagine, can we use this sine, cos, tan in real life? I feel yes. A very simple example, when you stand somewhere on the ground and when you look at your window or your balcony, somewhere about 3rd floor, 4th floor or 5th or 6th or 7th, whichever floor you stay on. Now when you call somebody, you have to raise your head. You have to just pull up your head like this, something like this. Hello mom, can you hear me? Or if in case mama is calling you when you're playing down and when you're playing for like several hours and you have not come up, and when mama looks at the watch and she thinks, oh, my child has been playing for let's say 4 hours, 5 hours. Let's call her up or let's call him up. So when she calls you from top of the floor somewhere 5th, 6th, 7th, she will always bring her head down. Like she will call you like this. Hello beta, please come up. Something like that. Okay. Or let's take one very beautiful example. This example is for college going kids. If in case, they are passing by and all of a sudden they saw somebody on the balcony. Now they want to see something on the balcony, but yes, again they have to raise their head. So when they are raising their head, they have to raise their head. Now, why I am emphasizing on raising your head? Mom is looking at you like she has to pull her head down. Why? Now again I am talking about angle. Again I am emphasizing on angle. Heights and distance is nothing else but dealing with my trigonometry basically. If I talk about a building is perpendicular to the base. Building is standing perpendicular to the ground. So what is happening? If I say this is my building, this is my, let's say my mom stays on the 5th floor. Even I mean to say I'm staying on my 5th floor. So mom calls me from here. I'm standing somewhere here. Okay. The mom has to see me, see me somewhere here. So to see me, what she has to do? She has to pull her head down. मतलब head down in the sense, सोने वाला head down नहीं भैया, उसको नीचे देखना पड़ेगा तुम्हें. ठीक है? जब उसे नीचे तुम्हें देखना पड़ेगा तो बेसिकली उसने क्या किया? मम्मा ने क्या किया? मम्मा ने अपना जो सिर है वो झुकाया. जब सिर झुकाया तो अभी हम लोग यहाँ पर क्या देखते हैं? हम लोग यहाँ पर साइट, we look at the angle of sight. Now what is angle of sight? Angle of sight, for example, if I'm standing still like this, so what is the view? Now this is exactly 90 with respect to my with respect to my ground. So the moment I change my head, the moment I move my head, what is happening is I am changing the angle. So now the angle which I am changing over here, suppose this was let's say 0 because now this is parallel to my ground. Okay, so now what is happening is now I'm making some angle with respect to my this level. Okay, now there is going to be some angle which will be created. Now this angle we are going to learn. Now we are going to say this angle to be angle of elevation. Okay, I will draw the image. Now later in the second case or second example, when somebody is calling you from top to the ground, now she has to bend her head down like this. Now in this case also, the angle which has been created, it is downward. Earlier the angle was upward. Now we are able to find two different ways of looking at a person or at an object. Now when I say looking at an object or looking at a person, if somebody stands at the ground and he is looking at the person on the 5th floor, he has to take his head up. So now the angle created over here will be called as angle of elevation. I will draw a proper diagram, angle of elevation. Alright, this is the first case. Now second case, what is happening is, now suppose your mama is somewhere on the top. Now the sight of vision, we can say, that's a proper word. Sight of vision is somewhere here. Now why we always emphasize on the sight of vision is because sight of vision is parallel to the ground. So it is parallel, so the angle made is 0. There is no angle created, and the angle made is 0 because it's parallel. And the moment I bring my head or I tilt my head in order to see the object which is over here, okay, now there is some kind of an angle which has been made. Now this angle which is created over here in order to see the object standing on the ground, now this angle is nothing else but the angle of depression. Okay, again I will emphasize on the word angle of elevation, angle of depression, angle of elevation, angle of depression. अरे भैया एक चीज बहुत क्लियर बता रहा हूँ, अगर तुम्हारी कोई गर्लफ्रेंड चौथे फ्लोर पे खड़ी है, तुम नीचे खड़े हो, तुमको अपनी गर्लफ्रेंड को बुलाना है, तो क्या करोगे? तुम अपने सिर को उठाओगे, और तुम जब अपने सिर को उठाओगे तो क्या करोगे? तुमने एक एंगल क्रिएट किया है, उस एंगल को हम एंगल ऑफ एलिवेशन कहते हैं। और दूसरी तरफ तुम अगर रोड पे अपनी गर्लफ्रेंड के साथ मस्त में घूमते हुए जा रहे हो और ऊपर से तुम्हारी मम्मा ने तुमको देख लिया, ठीक है, तुम्हारी मम्मा ने तुमको देख लिया और वो ऊपर से तुमको चिल्लाएगी, बेटा जरा ऊपर तो आना, ठीक है। तो जब तुमको नीचे वो देखेगी और तुम्हें बुलाएगी, उस समय वो जो एंगल बनाएगी ना बेटा, उसको हम कहते हैं एंगल ऑफ डिप्रेशन, और सही नाम कहा गया हुआ एंगल ऑफ डिप्रेशन, बिकॉज आफ्टर दिस मूवमेंट व्हेन यू आर कॉट रेड हैंडेड you are going to be under depression only. So please remember angle of depression, okay, angle of elevation. So basically why I am emphasizing on the word angle of elevation and angle of depression, so basically now this whole chapter, heights and distance, deals with angle of elevation and angle of depression. So this chapter is basically the application of sine, cos and tan, where we are going to use them in real life, and the best examples are going to be something about towers. An object is being placed to a certain height, and when any object is being viewed from a certain height to a certain angle, what will be the height of the person, you know, what will be the height of an object from the building, or like what will be the height of the building if suppose the person is standing somewhere 5-10 meters away from the building and he makes an angle of elevation. So these kind of examples we are going to see in heights and distance. So it is not at all a difficult chapter, it is a very nice chapter. So this is the basic concept of heights and distance. So we just have to understand two concepts. One is angle of elevation and the angle of depression. And angle of elevation and depression is always created with sight of vision, and sight of vision is always parallel to the ground surface. Okay, this is the first part. Now second part, beta, while solving the sum we will come across with few things. Always remember, again in my first video I have always emphasized on shoka toward or kosha chota. Sine opposite upon hypo, cos adjacent upon hypo, and tan is opposite upon adjacent. So while solving heights and distance sums, we have to more specifically use tan theta, okay, but some way or the other we can also use sine theta and cos theta. But there are few specific kind of sums, like for example, now where you are supposed to, you know, change sine tan theta into cot theta. So this is the kind of sum which will be asked in your board. 2011, now this sum came in 2011. So in this sum what they are asking is, they are asking a man observes the angle of elevation of the top of the building to be 30 degree. He walks toward it in a horizontal line through its base. On covering 60 meter, the angle of elevation changes to 60. Find the height of the building, correct to nearest meter. Now, in this kind of sum, what we are going to do? First, kids, we should always have an approach toward the sum. Whenever we start with the sum, we should always, be clear what they are asking. Knowing the concept is a different thing, but trying to understand the kind of question they are asking you, that is very much important. So approach is very much important factor when you want to solve a sum. So now first, it's very clear that a man is standing on the horizontal line and there is a building. So when he makes an angle of elevation toward the building, so first angle of elevation which he makes toward the building is 30 degrees. That's the first information given to us. Second information is given to us that when he walks toward the building, so he's walking toward the building. So when he walks toward the building and then after that, sorry, my bad, I came this side, I had to go on that side. So earlier when I was standing here, so when I looked at the building, my angle of elevation was 30 degrees. But now when I'm walking toward the building, okay, and now when I'm standing, after covering a distance of 60 meter, now when I'm looking at the building, now this time the angle of elevation which I have created is of 60 degrees. Okay, so something changed. When I covered a distance of 60 meter, the angle got changed. One thing which I want to tell you all, when you are far away from the building, the distance is larger, the angle created is always less. So you will always make a smaller angle when you are far away from the object. So the angle of elevation will be always smaller when you are far away. When you approach the building or like when you are going closer to the object, what will happen? The angle of elevation will increase. So never make a mistake. Now I have seen kids making mistake when they solve a ship sum. Like for example, the ship was earlier somewhere and it was coming at a constant speed. After traveling a certain distance, when the angle of elevation was made or the angle of depression was made from the lighthouse toward the ship, so that was different. Earlier it was 30 degree, now it was 60 degree. Why? So because when you are far away from the object, the angle of elevation or the angle of depression is always lesser. So when you are covering a distance and when you are approaching toward the object, what will happen? The angle of depression or the angle of elevation will always be higher. So please keep this thing in your mind that when you are closer to the object, angle will be higher, angle will be larger, and when you are away from the object, the angle will always be smaller. Okay. So now we'll draw a diagram on this sum. So let's make a diagram for this. Now I am standing, let's say here. Okay. Now I am drawing a building somewhere here. Let's say this. Now earlier my baseline is this basically. So this is the baseline which I have created. Now when I am looking at the building, I am creating an angle of 30 degrees. Now they have told us that the angle of elevation at the start is 30 degrees. Now after traveling for 60 meter toward the base of the building, and please always remember any object standing will always make 90 degrees with respect to ground. So the angle, so this kind of figure will always be a right angle triangle, so never get confused with this. So angle B is a right angle triangle. So now what is happening is there is a guy over here. Let's see, it's me only basically. So I was standing over here and I was looking at the top of the building. Okay, and at that time the angle of elevation was 30. Now I have moved to a distance of let's say 60 meter. Now I am standing somewhere here. Okay, now I am standing here. So when I'm standing here, now when I'm looking at the top of the building, the angle of elevation at this moment is 60 degrees. Okay, and I don't know the height of building. Let's assume it as h. So I need to find the height of h in the nearest meter. So I just have one information given to us that this much of distance I have traveled. Earlier I was at position C. Now I have come to position D after traveling a distance of 60 meters. So this is the given information which we have got. Now we have to find this value height. Okay, we don't know this. This thing is missing. Only this much we have. Now approach I was talking about. Now please better look at the triangles. How many triangles we have formed in this? We have formed this one triangle and the bigger one and the bigger triangle. Okay, bigger triangle is ACB or ABC and the smaller triangle is ABD. So we need to find, so what I can do is I need to find this. So I am going to see what is the common part, what is the common area for my both the triangle, or like what is the common side for my both the triangle. AB is my common side for my both the triangle. ABD and ABC. So now first I am going to take smaller triangle ABD. Okay. So now in triangle ABD, angle B is equals to 90 degree. Please students, I am writing the way how you are supposed to solve the sum in your paper. I am not missing anything or I am not giving any shortcut as of now. Shortcut part will be done later, or maybe I will create a short a part after this video is done. So now in triangle ABD, angle B is equals to 90 degree. Now what angle or like what trigonometrical ratio I can use for height and for base? For height and the base. So we have got opposite is height and adjacent is base. So can we use tan theta? Yes, again I will write down my shortcut over here, or OSHA chota sine, cos and tan. Sine is O upon H, cos is A upon H, and tan is O upon A. So I am going to use tan theta over here. So therefore tan 60 is O upon A. Now what is my O over here is AB and A is BD. So therefore, now what is my tan 60? We don't know the value of X, we don't know the value of AB, we don't know the value of BD, and also what is tan 60. In the previous video we have already done what are the standard angles. Tan 60 is how much? If you don't know exact value, you can always do tan 60 is sin 60 upon cos 60. So it's a shortcut, not shortcut, in fact it's a long cut. Sin 60 upon cos 60. Now this option I am giving you only if you don't know exact value of 60. Tan 60, what is the exact value of tan 60? If you don't know, no need to worry, no need to get panicked, just get back to basic. What is my base? Tan is always sin upon cos. So tan 60 will be sin 60 upon cos 60. What is my cos 60? Cos 60 is root 3 upon 2. Alright. Now what is my sin 60 was root 3 upon 2. What is my cos 60? Cos 60 is 1 by 2. So 2 got cancelled. Answer is root 3. So root 3 is equals to AB upon BD. Okay. So we got one value over here. AB upon BD is equals to root 3. So can we find AB in terms of BD? So AB is equals to root 3 BD, or simply we can write H is equals to root 3 BD. Okay, give it number 1. So this relation I got from the smaller triangle. Now we'll take the bigger triangle. Okay. Now in the bigger triangle, so we are having triangle ABC. So in the bigger triangle, we have triangle ABC. Angle B still remains 90 because it is perpendicular to the base. And again I will use tan 30 because it is opposite upon adjacent. Tan 30 is opposite upon adjacent, which is AB upon BC. Upon BC. But what is my BC right now? BC is equal to CD plus BD. So it's BD plus CD. Alright. Now CD ka value is how much? 60 degree, and BD will remain same as it is. So BD plus 60. So we got BC ka value as BD plus 60. Now substitute the value of BC as BD plus 60. And AB, what was my AB? AB was equals to H. So H upon BD plus 60. Now we also have one relation over here. H can also be written as root 3 BD. So sin 30 is root 3 BD upon BD plus 60. Now something is common over here. Now listen students, one more thing. Now I am using over here the name of a triangle, the side of the triangle BD, BC, AB like that. If in case you are getting confused with the namings, you can always use shortcuts like short forms, like make an assumption, let BD be X or let AB be X and Y, something like that. How I assumed for AB to be H. Similarly, I could have assumed BD to be Y because H I had already assumed over here. So BD I could have assumed X or Y, and CD was already given to us, which was 60. Okay, so just for your easyment, we can do let BD be X. Okay, so I am assuming BD to be X. So now I will replace everything in terms of X. So sine 30 is root 3x upon x plus 60. Now what is my sine 30? It's sine 30 is 1 upon root 3, which is the exact value of tan 30. But if in case you don't know tan 30, you can use the same rule which I did for tan 60. Sine 60 upon cos 60 we can use, and we can get the answer. So this will become how much? 1 upon root 3 is equals to root 3x upon x plus 60. Now it's a normal calculation we can do now. I'll just cross multiply the whole thing. So I will have x plus 60 is equals to root 3 into root 3x. So x plus 60 is equals to 3x. So I will take my x on that side. 60 is equals to 3x minus x. 60 ka value is 2x. 60 upon 2 is x. So x ka value will become 30. So height of the building is how much? 30 meter. So height is how much? 30 meter over here. No, height is not 30, my bad. I'm so sorry. BD ka value was 30. BD ka value was 30, which was x, which I assumed to be x. Okay, now we need to find height. Now height is equals to what? H is equals to root 3 BD. So therefore height is equals to root 3 into BD, which is root 3 into x, which is, now x ka value is 30, it is 30 root 3. 30 root 3. Now this is the actual height of the building, but they are asking you the answer in the nearest meter. They are asking you the answer in the nearest meter. So nearest meter, students, you need to know the values of root 3. Just remember certain values such as root 2, root 3. Root 3 ka value is 1.732 to be more specific. But yes, if in case they have already given you the value of root 3 in your sum, then use that value. Otherwise, remember root 3 value is 1.732. So I am using root 3 to be 1.732, but they want the answer to the nearest meter, so I'll just multiply them. So I will get 3 into 17.32. 3 2s are 6, 3 3s are 9, 3 7s are 21. 1, 2, 3 1s are 3 plus 2, 5. So it is 51.96, which is approximately 52 meter. So finally we got height of the building, which is 52 meter. Okay. So yes students, so we have done one board sum of heights and distance. So this kind of sum is going to be can be expected. कुछ नहीं डरना है, कुछ नहीं करना है, बस सिंपली एक सिंपल सा रिक्वेस्ट मैं ज़रूर करूँगा सभी से कि प्लीज़ प्रैक्टिस करो. जितना तुम सम सॉल्व करते हो, जितना प्रैक्टिस करते हो, शॉर्टकट्स बहुत हैं. यू कैन सी मेनी बुक्स, और सारी बुक्स में तुम्हें कुछ ना कुछ तो मिलेगा ही मिलेगा, ऐसा नहीं कि नहीं मिलेगा. बट बेटा मैथ्स एक ऐसा चीज़ है जो बिना प्रैक्टिस किए नहीं आता. अगर तुम बहुत स्मार्ट भी हो, अगर तुम्हें बहुत अच्छे से मैथ्स आता भी है, तो वही कहावत मैं ज़रूर कहूँगा कि अगर चाकू को शार्प ना किया जाए रेगुलरली तो चाकू ब्लंड हो जाती है. वही सेम चीज़ बेटा हमारा भी हालत है. हमें भी रेगुलरली मैथ्स प्रैक्टिस करना चाहिए. रेगुलरली अगर तुम्हारे पास टाइम नहीं है तो एटलीस्ट ऑल्टरनेट डेज में मैथ्स निकालो, मैथ्स को प्रैक्टिस करो, विच विल ऑलवेज help you to build confidence while solving the sum, and the approach toward the sum has to be there, and that will always come after practice. तभी कहा गया हुआ है कि मैथ्स और एक केमिस्ट्री दो सब्जेक्ट ऐसे हैं जहाँ पर हम पन्ने भरते हैं. जहाँ पर हम पन्ने भरते हैं, वो बेटा पन्ना भरना चालू करो, बुक्स खत्म करो, या दिया घर पे लाओ, या दियो को तुम किलो के हिसाब से लाओ और पेपर सॉल्व करो। ठीक है, दैट्स इट बेटा फॉर द डे। हमारा आज का क्लास यहीं पे हम एंड करते हैं। थैंक यू सो मच फॉर वॉचिंग। हैव अ नाइस डे। राधे राधे, जय श्री कृष्ण।